Hello, everyone. Welcome back to Data Analytics using Microsoft Excel. Hope I'm audible and the screen visible to all of you. We will start with a recap of the last session as we always do. So today is day 13 of our program. And yesterday we had looked at a few more graphs, a few more ways of representing the data in a graphical format. Since the past 2 days, we are focusing on the visualization aspect, different types of charts that we can create using Microsoft Excel. So we saw tree map, how it is used to present hierarchical data, Pareto chart, which is based on the 80-20 rule. We looked at waterfall chart, which shows the cumulative total at the same time, the individual contribution. Then we looked at funnel chart, which is used to create when we have data going through different stages in a process. And when it moves from one stage to another, when it experiences progressive reduction. After that, we saw how we can bring these graphs together into one common sheet. And that sheet, which contains multiple charts presented in one go, is referred to as a dashboard. You can even call it as a report. So this is what we had covered yesterday. Today we will continue. We will look at building a basic interactive dashboard. How do we make the graphs in the dashboard interact with each other is what we will see. Then we will be looking at the concepts of forecasting, scatter plots creation, their purpose, and we will talk about regression. Okay, so this is the idea. Let's get started with basic interactive dashboard. Sorry, there's a spelling mistake there. Okay, so here I already started creating a few charts so that we wouldn't have to spend time creating the charts. I'm using the orders data from yesterday, okay, where I told you that this is called as superstore data, where different variety of items are being sold across different states in various regions. So what I have here is a pivot table, okay, which is showing the regional profit. Now I'm focusing on the country, Canada. Now look at how I have created this. Let me show you the field list. I have country in the filters shell, so I can choose from the list of countries. Let's say Canada now. If I choose United States, it will get updated showing me the data for the US. Okay, and we are looking at data for various regions. The information is profit. Then I have state-wise profit over here. Again, even for this, you can see state-wise profit and country is the filter. So depending on which country we choose, data for that country is going to show up. All right, so this is my other chart. Then I have a chart where I have created another column chart showing the top 3 customers. So look at the graph here. We have customer name and we have values. Okay, so how did I get only the top 3 customers here? Is basically I put a filter, values filter using this option top 10. So once I select top 10, you see here, this is where I change the number to focus on the top 3 customers. Okay, so these are the 3 graphs that I've already designed. Now we will see how to create a report or a dashboard by putting these 3 together in one place. So I'll just open a new worksheet by clicking on the new worksheet icon there. And there is the new worksheet, which I will call as the dashboard. Now you can decide what should be the structure of your dashboard. Okay, you can just go ahead and, maybe use a nice background color, then present your data on that graph, something like this. Now here, I will just say that this is profit analysis dashboard. Okay, profit analysis dashboard. Now, because this is the title, I wanted to just spread across like that. I'll use merge and center, make it bold and increase the font size. Profit analysis dashboard, okay, is what we are trying to create. Now, I will place the graphs in here. How do we place the graphs? Like we saw yesterday, we will copy the chart with the Control C. Then go to the dashboard and paste it wherever you feel would be relevant. I want it here. And I don't want to give so much space for it. It's a small graph. I think that much would be enough. The next chart I will take is the state-wise. Okay, let me take the top 3 customers next to it. And I will place the top 3 customers right next to it over here. Adjust the size. Finally, I need the state-wise profit graph. So I'm going to copy that also, Control C, and I'll come here and paste it down here, Control V. I will make it slightly wider. These are the 3 graphs in my dashboard. Okay, move it closer to these 2 graphs, the little gap in between. All right, this looks good. This is my dashboard. Okay. Now, just to make the whole thing visible on one screen, I'll make this slightly smaller. Okay, the zoom. All right. So this is something we had already discussed yesterday, isn't it? We already talked about how to do this. Now, what else are we going to learn here? We will talk about inserting slicers. Okay, on a dashboard, how do we insert a slicer? So I'll keep this selected. I will go up to Pivot Chart, Analyze. And here we have an option to insert slicer. So I'm going to select that option, Insert Slicer. Now it's showing me list of all the fields. Okay, means that from the data source which was used to create this particular graph. Complete list of fields with which this graph is associated, the underlying data source. These are all the fields. I need a filter on region. I need a slicer on region, and I should be able to select, let's say, country also through a slicer, or let's keep state and province. We already have country here. Okay. So now 2 slicers will come. One that is by region, the other which is by state and province. 2 slicers are going to appear like this. Now I'm going to move this slicer and place it over here and adjust it. And I will move this slicer underneath the region and leave it there. Okay. So based on the region selected, this should get updated. And what we can do is, for this slicer, because we have a lot of data, I'll go up here to the slicer contextual ribbon and increase the number of columns to 2. So you can see how the names of the states are now arranged in 2 columns. Maybe increase the width, isn't it? We can make this bigger because we are using 2 columns. We might want to see the names nicely, clearly. This one also, let's match it with the one below by increasing the width. Okay, so these are the 2 slicers. Then slicers also have a contextual ribbon. If you want it to match with the background, you can change that as well. So here, this is basically how we create an interactive report. And how are we making it interactive? Because we have our slicer in here, isn't it? So if I choose only central, look at how the child filter, meaning states from central region, are appearing. This is showing us data only for the central region. Okay. If I choose east, this map does not seem to be getting updated. Okay, but only the pie chart is getting updated. South, this map isn't getting updated. Or if I go with the other one, west, okay, based on this, what I'm selecting here, accordingly, things have to change. It's not happening. So I'll just clear the filter. Now, on this slicer, when we do a right click, we have something called as report connections. Which all or which other sheets is this supposed to impact? We have the same option up on the slicer ribbon also. There is report connections here as well. From anywhere you want, you can select it. Now, I want this slicer, the region one, to impact the state column chart as well as the top 3 customers chart that is available. Okay. So I want it to impact both of them. Now, top 3 customers, I'll make a small change here. I am going to go ahead and add the data labels. So let's just add the data labels so we can see what is the profit coming from each of them. And maybe a little bit of formatting would be good. Yeah. So this is, I think, okay. Now it is looking good. Let's go back to the dashboard. Let me do one thing. I'll just copy this again. Come here. And paste it back. Wait a little bit. So we can give this a little extra space. Okay, right. So now what did we do? Through report connections, we established a link between these, isn't it? I went to report connections and I have associated them. They are all together now, which means when I choose a region, you will notice everything getting updated. Okay, so if I clear the filter, just observe the data first. We have 4 different regions. We have data for a lot of states, so many of them. And you can see the top 3 people, Raymond, Sanjeet, and Tamara Jan. Okay, and the figures. Maybe it is very small, but I will maybe zoom it in a little now. Okay, so this is basically what we are looking at. Now, when I choose central, you can notice all the charts have updated. It's not Raymond anymore, right? It's changed to Adrian, because in central region, these 3 people are the most profitable customers. And the states operating in the central region is what we are able to see. Suppose I change it to east. So from eastern region, these are the states. We can see New York is the most profitable. Ohio is the least profitable. And we can see the customers, top 3, Tom Ashbrook, Hunter Lopez, and Daniel Raglan. If I change it to southern states, okay, we have Virginia with very high profits. We have North Carolina with the least profit. And these 3 people are the most profitable customers from south. And if I choose west, accordingly, it's getting updated. All right. Now, if we go ahead and click here, we know that we will be allowed to make multiple selection. So east and west collectively combined together, these 3 are the most profitable customers. If I take, central and west, it was now east, central, west. Now south, central, east, west, all of them are selected. So the most profitable customers from all the regions put together. Data from across all the states put together. Profits from across all the regions put together. Getting it? So like this, we can make the charts interactive. And when the user selects certain member, we are allowing them to see data pertaining to the selection made. Rather than showing all the data or something that is not relevant, we are showing relevant information over here. That is the beauty of slicers that you create through and apply on the pivot chart. And one more thing is the report connections part you have to observe. Now, on top of this, I will also insert one timeline. This is also something we had discussed earlier. I hope you all remember. And as I do, I hope you will recollect. Insert timeline. So here for order date, the date when the orders are placed for various products. Now up here, I will go and place the timeline slicer by adjusting the color to match with the background of the report. Bring it down here. And I'm going to make it utilize all the space available because we have data for a lot of years. We have data for 4 years and we have data for a lot of months. Okay. You can see the slider. Okay, let me just. Okay, this is by months. Let's go by years. quarters. Okay, it's expanding, months. And then we can even go at day level, but that would be too much. Let's keep it at month level. So you can see we have data starting from 2011. Suppose I want only for 2019. Accordingly, you can see it has changed. Now, Jan of 2020. Okay, then if I increase this, say I want up to November and December of 2020. You can see this getting updated. Again, notice that only this is getting updated, isn't it? This is not changing. All right, so this slicer also has to be updated with report connections. It is impacting only the pie chart. Let us make it impact the other two also. So now, based on the time period that I select, it's going to update. So if I look at the performance of the business in January 2020, you can see the profits. You can see the top 3 customers of that month and state-wise the profits of the different states in that month. Okay, so suppose I take May over here. Then the most profitable customers of that month, profit share across different regions and state-wise. Now, if you go there and expand it across months, then across all of these months, the performance. These figures are changing. If you notice, these numbers are also changing and the state's data is also changing. All right. So I hope you all understood how to create an interactive dashboard in Excel. How slicers, timelines, report connections will help you create whatever you might want to create and present it in a very nice way. So this was about basic interactive dashboards using Excel. We shall now move on to the next concept, forecasting. Yesterday itself, the data has been shared with you, which is called as forecast data. Okay, you can just see that data is there. Now we'll use this data to perform forecasting in in Excel. Now, one thing that you have to keep in mind is if you would like to use the forecast feature, the time series data that is available. Now, first of all, what is forecasting? Forecasting is where we take the current and the historical data. We would take old data, time series data, that data that has been collected for over a period of time. We take that data and using the past performance information, we would go ahead and predict the future values. Okay, using the current and the historical data. Current data if it is available, otherwise whatever data is available, historical data, time series data, and predicting what the future will be like. Estimating the future is called as forecasting. Okay, so we need time series data to perform forecasting. Time series data means data that has been collected for over a period of time. And here, one prerequisite though is that these timelines, they should be evenly spaced. Okay, means if I have data for Jan, then if I have data for Feb, then March, April. So they are evenly spaced, right? 1 month, every month. For every month, I have the information. If I have it at random, if I have for Jan and then for April and then for December. So the spacing is not even, isn't it? From Jan to April, the spacing is 3 months of gap. But April to December, the spacing is quite a lot of months. Then it will not work. Whatever time series you're taking, be it years, quarters, months, weeks, days, whatever it might be, they should be evenly spaced. I hope you all understood the point of evenly spacing the time. Then the data, of course. So you can see that I have data. Some sales figures are there, but I don't have it for the month of February. Okay, I don't have it for Feb. I have it for the rest of the months, but I have it up to April 2022. Let's say I want to estimate till the end of 2022, or I want to estimate even for 2023. So how do we do the estimation? What will the sales be like in the future is what I would like to find out. So using this data, I have to figure it out. How do we do it? We can go up to the data ribbon. Okay, on the data ribbon, here is a forecast group. Forecast. And you will see something called as forecast sheet. If it is not available on your version of Excel, then it might not be there. So here I have it on Office 365. This is forecast sheet. So when we click on this option, forecast sheet, it is just called as one-click forecasting. We don't have to do anything. We just have to go and click on that option. The moment I click on that option, it has selected the data and it is presenting us with the forecast output. Okay. Now, what did it do? It is taking the historical data, Jan, Feb, March, April, May, whatever data I have here, all the way up to what? April 2022, isn't it? So till here it has taken the actual data. The line that is coming in blue is the actual data. And then we can see the orange line, isn't it? That is the forecast. That is the estimated values which are being presented to us. And apart from this, you will see two other lines, one line above the estimated value and one line below the estimated value. This is called the precision range. Okay, I'll go up to data layer, data driven, and click on forecast sheet. It's going to show me the forecast. So we will try to understand a little about this forecasting. This area here is referred to as the precision range. Will come there. Now you can notice that I do not have data for Feb 2021, isn't it? I don't have data for this, but it has taken some value by default. How did it do that? Next thing, what are these lines indicating? Lower confidence bound and the upper confidence bound this year. And forecast end. So it has estimated till the end of that year, till the end of 2022. What if I might want to extend it into 2023? All I have to do is click on this calendar, end your forecast at this point. When we click there, we can choose a different end date. So I want up to, let's say, 31st of March 2023. You can see it got extended accordingly, right? It got extended accordingly. So if I don't want it till there, I want it only up to October or September. So when I go ahead and do that, you see it got, let me just change it to September and pick a date from there. September 30th. So you see, it is estimating only up to there. So how do you decide the forecast length? Forecast length meaning how far into the future do we want to go and do the estimation for? How far into the future? So that is called as the forecast length, which is this line. Next, as I told you, it gives us the estimated data, the forecasted data, but no model can give us 100% accurate result. If Excel is saying that this will be the sales in May, this will be the sales in June, this will be the sales in whatever August, okay, month. Can we be 100% sure that definitely so and so sales will happen? We can't, because no machine learning technique can give us 100% accurate result. Little bit it could fluctuate. Okay, little bit it's definitely expected to fluctuate slightly more or slightly less than whatever is being estimated. So by default, we operate at a confidence interval of 95%. You can see down here, there is an options, a small arrow mark options. So when I click there, it will expand. Forecast is starting at so and so day and the confidence interval is 95%. Okay, meaning there is a 95% chance that the actual sales of that month will fall in this range. It will lie between the upper and the lower bound. It will lie in this range. It's likely to be this value, but definitely it will lie in this range. If I don't want to be very confident, I can just reduce the confidence interval. As I reduce the confidence interval, observe this area here. You can notice how those lines are coming closer together. They're coming closer together. We're just 69 or 70% confident that it will fall in this range. So the confidence interval is directly proportional to the precision range. You want to be very precise, you have to increase the confidence interval. When you increase the confidence interval, the range becomes wider. We are saying there's a 95% chance that it will definitely fall in this range. There is only 5% chance that it could be above or below what we have estimated. There is only 5% room for error here. Okay. If I want to be more confident, 96, 97, 98, this range becomes much wider. Now I'm saying I'm 99% confident that it will fall in this range. So when you give such a wide range, obviously it has to fall in that range, isn't it? It would definitely fall in this range. The probability that the actual sales in that month will lie between the lower and the upper bound is pretty high, 99%. When such a wide range is given with all the estimate, it's not some randomly, we didn't pull out some numbers from the air, right? We have done this based on the past trend. So it has to fall in that range, but with just let's say 75% confidence. Range becomes smaller because we are keeping larger room for error. We are saying there's a 75% chance that it will fall in this range. There is a 25% chance that it could be more or it could be less than what we have estimated. Okay. So I hope you all understood the relationship between the confidence interval here and the precision range. Smaller the confidence interval, smaller the precision range would be, larger room for error. Larger the confidence interval, wider will be the precision range, reducing the room for error to just 5% now, because I'm using confidence of 95. Okay. Next thing is about here. Just a moment. So this range is called as the precision range, which is directly proportional to the confidence interval. Okay. Next thing is this one I want you all to focus on. Filling missing points using. Fill missing points using. You see, we have a missing point over here. But what happened here, it is still taking some value for that point. That is because if in between this series, if there is anything that is missing as here, it will go ahead and do interpolation. Meaning using the data that is prior to it and using the data that is next to it, it will estimate what could be the value of this missing data point. Using the prior and the later, the before and the after points, it is estimating what could be the value of that missing point and it is doing interpolation based on that. Suppose you don't want this, the other option we have here is to make it 0. Now the moment I made it 0 over here, notice that this data point has come down. It is now at 0, isn't it? So if there are any missing data points, you can either leave it as 0 or we could ask the system to go ahead and do interpolation. Using the previous and the next marks, it will go ahead, data points, it will fill it in. All right. If there are duplicates anywhere, it will take the average of the data, which is good. Now, what is the timeline range? You can see that all these were automatically populated. Timeline range. From where has it been taken? It is being taken from A1 to A17. Column A from A1 to A17 till here. Okay, and values range B1 to B17. It is all absolute reference logged in place. B1 to B17. This is the range of values. Whether or not there is any seasonality in the data, it is detecting the seasonality automatically. If you want, you can also set it manually. Okay, so what is seasonality? Seasonality is the regular rise and fall or a pattern in the data. So let's say, okay, let's say this is my graph. The periodic rise and fall in the data at regular intervals of time. So when we break our data into regular intervals of time, more or less, if we see the same pattern getting repeated, then we say that the data is seasonal. Okay, otherwise it is not seasonal. So in this case, is there seasonality? In this case, if you notice, This is monthly data, isn't it? So almost like every 4 months, you can see this data point here. Little bit of seasonality is there. It's rising, then coming down. Okay, from April to May. Then next 4 months it rises, then it goes down. Then next 4 months it rises, then it goes down. Next 4 months it rises, then it goes down. So similar kind of a pattern is being maintained. So we can say there is some sort of seasonality over here, which is automatically detected. Okay, then there is a concept called as trend, which is also automatically detected. Trend is basically the overall direction in which your data moves. So over a period of time, if you see it going slowly upwards, like over here, it is actually going upwards, there is an upward trend in this data. Okay, you can see if your data is going somewhere like this, there is constant trend. It is neither increasing over a period of time nor decreasing. So there is a constant trend. If slowly you notice it going down, then we say there is a downward trend. Okay, so trend is what? Trend is the overall direction in which your data moves. And Excel detects all of these things. The forecasting feature that is available here detects all of these things automatically. It is detecting the trend, it's detecting the seasonal pattern, okay, and it is estimating based on all of that information. So this is forecasting in Excel. Now, you can also go and use, by default, it is always a line, as you can see on the top right corner. If we want, we can even go and select this icon to create a column chart. So how do we read this column chart? All the other options are the same. Nothing has changed. Okay. The place where the forecast is ending. Okay, you can change the forecast length. From where are we taking the data into consideration? Confidence interval. It is going to detect the seasonality automatically. Timeline range, value range, missing points with interpolation, all this remains. Only the visual representation is changing. So you can see first 4 months increases, then decreases. 4 months increases, then decreases. Increases, decreases, increases, decreases, increases. And you can see the same pattern getting carried forward. Okay. Here, all this in blue is the actual value, and the one in orange is the forecasted or the estimated values. Now, how do we know about the upper bound and the lower bound here? You can see a gray colored line, isn't it? This one, you can see a gray colored line on every bar. So this is the lower bound. This is the upper bound. We are estimating that the sales will be so and so value. But no model can give us 100% accurate result. We can't say that definitely 100% it will be this. It could fluctuate a little bit. So it can be anywhere in this range from here to here. And how confident are we that it will definitely fall in that range? 95% confident. Means there is still a 5% chance that it could be lesser or more than what we have forecasted. Okay. I will show you all one graph here. Let's just click on create now. You see, once I click on the create button, it has given us everything. So some forecasting statistics, any data scientist who would be asking you for this data, you can provide them. We have the actual data. We have the forecasted sales. We have the confidence interval. So upper bound would be this plus the confidence interval. Lower bound would be the forecasted sales minus the confidence interval. Okay, and the graphical representation is also here. But of course, I have taken columns. You might want to take lines also. That is fine. Let me just maybe undo that. We'll just go ahead and create it with the line only, okay? With this. So when I create it, you can see the line coming up. In a new worksheet, it's opening this. In a new worksheet, it is showing us this data. So we are talking about the upper bound and the lower bound, isn't it? So how do we calculate this upper bound and lower bound? If you present it as a line, it has already calculated the upper confidence bound and the lower confidence bound. Okay, forecasted sales and the confidence bound. So here there is some problem, but from here on you can see it is calculating. This is the estimated sales, the lower bound and the upper bound. Estimated sales, lower bound and the upper bound. Now, if I go ahead and use a column chart and create, it's showing us slightly one small change here is it's showing us the sales and the confidence interval. So the lower bound will be this minus this. Upper bound will be this plus this. So this value plus this value, upper bound. This value minus this value will be the lower bound. So if you're using line, that will come clearly. If you're using a bar graph and then if you create the forecast output and save it as a sheet, then this is one small change that you might want to note. Most of the time, people go with the line. Most of the time, when we say forecasting, because it is time series data, everybody would expect to see a line chart. Okay, so this is about forecasting. If you'll have any doubts or questions, I shall take up. I will just connect to YouTube. Swarupa, I think your question was here on the dashboard, right? You saw, right? We do get the scroll bar. So I think that is clear. Maybe you were talking with respect to this, the scroll bar on order date. Predict the future. Yeah, right. So, okay. So no questions so far, right? All right. Let's proceed then. The next thing we are going to talk about is how to create scatter plots and then how to perform regression, which is predicting the value of a certain variable, which we refer to as the output, based on some other variable, which we refer as the input. Okay, now what exactly I'm trying to tell, I will show you here. Okay, so we are now going to talk about prediction. Prediction is also estimating the future value. It is also where we estimate the future value, but how is it different from forecasting? So prediction is where we estimate the value of an output variable, which is the dependent variable, based on some other variable, which is the independent variable. So like what will be the power output in a power plant given the wind speed in that locality? What will be the power output given the wind speed? So power output would depend on the wind speed, which means power output becomes the dependent variable. And what is it depending upon? The wind speed. So wind speed becomes the independent variable. It does not depend on anything. Based on the wind speed, the power output is going to change. Okay, so whatever is it that we want to predict, it is indicated with Y. We are expressing it as a function of X. This is what we do with prediction. Express the output, the dependent variable, as a function of the input, the independent variable. What did we do with forecasting? Forecasting is where we are predicting the value of certain variable, Y. What will it be in future? By looking at what is its current and the past performance. How many ever years or months or quarters of data that I might have? So let's say I have to estimate what will be the profit made by a business in 2023. While I am given information about the profit made by the business in 2022. I know what is the profit made by this business in 2021. if I know what is the profit made by this business in 2020, if I know the profit made by this business across different years. So using the previous data, current and the historical data, when we try to estimate the future, that is forecasting. Here, we are estimating based on the same variable's performance in the past. Here, we are estimating based on some other variable on which it would depend. Okay, like what will be the weight gained by a person given the calories consumed. Okay, so what will be my dependent variable y here? Weight. Weight gain is going to become the dependent variable. What will be the independent variable based on which the dependent variable will vary, weight will vary? The calories consumed, right? Based on the calories consumed by a person, the weight will increase or decrease. So this becomes dependent. This is the independent variable. So we are expressing this as a function of this. This is prediction. That is how prediction and forecasting are different. Both of them are estimating something, estimating the future. But one is based on its own previous performance, the other is based on another variable. Okay. Now, to go ahead and perform prediction, to express something as a function of something else, there has to be a relationship between the two of them. If there is no correlation, if there is no dependency between them, if they are not related, okay, then we cannot do prediction. So if somebody asks me, what will be the weight gained? How much weight am I going to gain? I will tell you what is the wind speed in my locality. You tell me how much weight I will gain. If I come to you and tell that I would like you to predict what will be my weight gain, and what data will I provide you? Not information about the calories that I'm taking or how much I work out. I'll not give you all that. I will just tell you what is the wind speed in my locality. Now, will it be possible to predict the weight gain depending on the wind speed given? It would not be possible. It is absolutely meaningless. Remotely, it might have some connection. We don't know. Direct connection, it doesn't have. So strong, significant impact, it will not have. So in order to perform prediction, first we have to check whether or not there is a relationship between them. Which chart will help us understand about the relationship is a scatter plot. Okay, a scatter plot. So given this data, I would like to predict what will be the power output given the wind speed. Okay, this is my question. So first I'll create a scatter plot to answer this question. Okay, how to create a scatter plot? One point to remember while creating a scatter plot is this. Whatever you're trying to predict goes on the y-axis. What goes on the y-axis? Whatever you're predicting, power output, it should go on the y-axis. Then on the x-axis, we will put an independent variable, wind speed. Generally, this is what a scatter plot should be like. Okay, dependent variable becomes the y. That is what we are estimating by expressing it as a function of x, the independent variable. So with this in mind, let's create one scatter plot. I'll show you how to create it here. All I need to do is select both the fields. And then I will go up to the insert ribbon. And I will go here under charts. This is to insert XY scatter plot. Okay. And I'll have to click on this. The moment I click on this, it is created. Okay. Excel has created the scatter plot and it is presenting the scatter plot to us. So let's just go. This data I have not shared because today only I thought I will cover regression. So I will share it along with tomorrow's data. I will share it. Okay. This one particular file I have not given. Any of you from Tableau, you would have this data in your data sources folder if you're enrolled. I will go with this because it's giving me the equation of the line along with the regression line. So I will go with this. Too many grid lines. Okay, let's keep it. Move this little here, I will move it. Okay. Make it bolder. Go there and yeah, I think this is good. These are not necessary. The line is not very prominent. Now, what is happening over here? This is a scatter plot where we have the y-axis and the x-axis. Now, unfortunately, what is happening here is power output is here. This is the power output. Okay. And this axis is the wind speed. It is the opposite of what we wanted. We want wind speed as our x-axis. We want power output as our y-axis. But it's happening the other way around. One point to remember, very important point to remember, when you create XY scatter, the column on the left side forms the x-axis. The column on the right side forms the y-axis. That is the catch. So there is no way where you can go and change the setting. It's not like we can go somewhere in here and we can swap it. Okay, it's not like we can go here and say, oh, no, interchange. Something went wrong, interchange. No, we can't do that. So what we have to do is we have to interchange this itself. All right. I'm going to delete this. And what I will do is copy the wind speed data, in fact, cut it and insert the cut cells over here. So I just cut this and moved it here. Now what is happening? This is going to become, this is the left side of the data, right? Of these two columns. And this is the column that is on the right. So now upon selecting these both, if I go to insert ribbon and insert a scatter plot, you can now see the relationship. Okay. Okay, let's add the trend line. Okay, trend line basically is the best fit line, a line that goes through as many data points as possible, showing the overall trend, overall direction in which it's moving. So the chart is ready. I'm going to just add a few elements to this chart. Up here, chart element, I will show the trend line, linear. I'm going with linear forecast, okay? You can see this line that has come up, that is our linear forecast. Along with the equation I wanted, here is the equation. Legends are not necessary, so I will remove the legend, make it none. This is better. Now, how do we read or interpret or understand the information given over here? What is that line indicating? This line is called as the trend line. This is the best fit line that goes through as many points as possible. Now, upon looking at this scatter plot, we can understand that there is a relationship between the input and the output. So here, this is our wind speed data from each and every row. Okay, wind speed is plotted, and this is our power output data. Okay. All right. So given this information, how do we know what is a scatter plot in the first place? I told you that it tells you the relationship between the variables, but how are we supposed to understand or interpret the relationship between those members there? Let me show you one scatter plot. So whenever we create a scatter plot, no, it will take a shape like this. We are plotting here X and we are plotting here Y, isn't it? Now, if you look at this, this is the XY coordinate plane, and every data point here will have some X coordinate and it would have some Y coordinate. Every data point, drop a perpendicular to the X axis, it's the X coordinate. If you drop a perpendicular to the Y axis, it is the Y coordinate. So it would have X and Y. Understood? So based on the wind speed and the power output, Tableau has plotted those data points. Okay. It has taken from every row, it has taken wind speed and power output. From each and every row, it has taken wind speed and power output, and it has plotted them. So everything is based on the X, that is wind speed, and based on the Y, that is the power output. This got plotted here. Okay, we have a lot of data here. We have about 200 odd points. So I hope you all understood what it is. So it is basically the XY coordinate plane where it has plotted the data. Now, by looking at the scatter plot, we can understand certain things. We can understand about the direction of the relationship. Okay, we can understand about the direction of the relationship. If you look at the first chart, it is positive. Positive. Why is it positive? Because if we increase, when the input is small, the output is also small. As we increase the input, output also has increased. So they are increasing together or decreasing together. There is a direct relationship. So the direction is positive. The direction is positive. Now here also, overall, you can see the data moving upwards. It is a positive relationship. They are direct. There is a direct proportion. Here we cannot really comment about in which direction everything is moving. So there is no correlation. It's not necessary. It should always that there should always be correlation. As I told you, if someone asks us to predict what will be the weight gain given the wind speed, there will be no relation, and you will get a scatter plot like this. No relation. Here, if you notice, there is a downward relation. And why did this happen now? Why did downward relation happen? There are many scenarios where it would happen. Now, let's say this is the discount. Okay, discount being offered on a product, and this is the profit that we are going to make. So if I'm going to offer, let's say 10% discount, I might make really good profit. If I'm going to increase the discount to 20%, I'm compromising on the profit. It will reduce. If I make a profit of, give a discount of 30%, my profit might further reduce. At 40%, even more it will reduce. At 50% further. At 60%, I might even go to a situation where I'm making a loss. So increase in one variable leading to decrease in another variable is a negative correlation. The direction of the relationship in such cases is negative. Or you take the example of depreciation. This is the number of years I have used a product. Let's say my phone. And this is the resale value. If I've used it for 1 year, people might want to, purchase it by offering a good, decent amount. If I've used my phone for 2 years and now I want to sell it, its value comes down. If I've used for 3 years, further comes down. If I've used it for 4 years, they might say no thanks. They might not even be interested in purchasing it. So this kind of relationship is a negative relationship. Okay, here also negative. Sometimes we have seasonal data. Sales of ice creams decreases in winter, increases in summer. Decreases in winter, increases in summer. So when you have that kind of a pattern, when you have a seasonal pattern or a cyclical pattern, you might get curvy linear relationship. Okay, sales of ice creams decreases in winter, increases in summer. Decreases in winter, increases in summer. That kind of a seasonal pattern in your data. Okay, then we say that relationship is curvy linear. So this is what a scatter plot will do. It will help you understand the relationship. Only when there is a proper valid relationship, estimation will make sense. Going ahead and predicting would make sense. Okay. So over here now with this data, we've estimated. We've created a scatter plot and we have our regression line. This line is the trend line called as regression line. Now, if the wind speed is going to be 10 meters per second, suppose the wind speed is going to be 10 meters per second, Can we estimate? Okay. If the regression mean speed is 10 meters per second, using the existing data, we can understand that power output will be around 15 megawatts. If it is 15 meters per second, power output would be around 28, 29 megawatts or 20 something. If it is 20, though we have not had that scenario, we are having a trend line. Trend line can be extrapolated and we can say it will be around 38 megawatts. If the wind speed is 100 meters per second, our screen is not enough to extrapolate the existing trend. This trend line is basically the overall trend based on the relationship between these two variables. Okay, we can't extrapolate beyond a certain point. That is where the equation comes into picture. Okay, this is the equation of the straight line. Y is equal to mx plus c, where m represents the slope of the line and c represents the y-intercept. C represents the y-intercept. So what is the slope? It is basically the inclination. You need to go back to your school days here. C is the y-intercept, the place where this line will go and touch the y-axis. If I extend it here, where will it touch the y-axis? Okay. So using this equation, we can go ahead and predict. So I would like to predict what will be the power output when the wind speed is 100 meters per second. All I need to do is substitute here. 2.244 multiplied by 100 meters per second plus the y-intercept, negative 6.4. Approximately, it will come to 218 megawatts. Approximately 218 megawatts. Getting it? So that is how we go ahead and do prediction. For whatever is the input value given, we are estimating the output by using the linear regression equation. Y is equal to mx plus c. Now, is this equation reliable or not? How to know that? We have another factor here called as R squared value. It is something that indicates the strength of the relationship. It is called as the coefficient of determination. And if it is greater than 0.8, we can use that equation. Okay, it is a strong relationship. So basically what this is telling is, how much would be the impact of wind speed on the power output? How strongly will wind speed impact power output? Almost 95%. 95.6% impact will be there. Okay. So they are very strongly correlated. If you change this, there's a 95% chance this will change. This will vary depending on this. Okay. That is R squared value. Now, if you want to run proper regression on this data, this is just a scatter plot with a trend line giving us the equation and R squared value telling us about the strength. That, okay, when you change wind speed, it is strongly related to power output. The strength between these two members, the relationship between these two members is 95% strong. Okay. Then up here on data, okay, here this version, let me go down to file, options. You can go and go to add-ins. Okay, and Excel add-ins are there. What we need under Excel add-ins here is the analysis tool pack. Analysis tool pack. Okay, when we add this, it's not showing me my analysis tool pack. Has to be there under data. Okay, I will show it to you tomorrow. I'll add the pack and show it. Okay, how do we run proper regression on this data? We will see it tomorrow. So I hope you all understood whatever we have discussed so far. If you'll have any doubts or questions on today's discussion, let me know. Otherwise, we can wind up here. And I request you all again and again, I'm saying this every session, but please don't mind. But please do like the video if you found any valuable information by watching this video. Please don't leave without hitting the like button. And anybody who has not yet subscribed to the channel, I request you all to subscribe. Tomorrow, we will see how to run the regression on the same data. And then we will proceed to looking at date and time functions. Very, very important topic. Quite often people, struggle a lot managing dates in Excel. So we will be looking at that. Date and time functions, we will spend significant amount of time understanding that. After that, we will look at how to connect to data from other sources. So far, we have been creating data in an Excel sheet and working over here itself, right? What if your data is present in some other file, like maybe in a text file? How do you bring data from a different Excel workbook in here? Okay, these kind of things. Get data option, we shall see. So tomorrow, first half of the session, we will be looking at date and time functions. Second half of the session, we will look at how to bring data from other sources into Excel and work with it. Okay, so that's the agenda for tomorrow. That's it from my side, friends. Thank you so much. Please join me tomorrow for the next session. It will be very interesting. And yeah, hit the like button before you leave. Thank you so much. If you have doubts or questions, I shall take up. Yeah, analysis toolpack has come, but anyway, we will do it tomorrow, okay? We will run the regression tomorrow. If I simply click on the regression option and click on OK, it will basically show us the regression statistics. We have to choose the input range. That's a lot of data. And then choose the output range. Anyway, I will repeat this tomorrow also, okay? I will just show you all how this is done tomorrow as well. Once this is selected, let's turn on the labels and click on OK. So regression statistics for maybe a data scientist, if you have to provide it to the data science team in your organization, whatever, trend lines you have put, the regression that you have done, you can go ahead and try this kind of thing. We shall see it tomorrow. Anyway. All right, friends. Thank you all so much. Bye-bye. See you in the next session. Bye.